Well, turns out developing anime AI is not an easy task. I've been making games for quite a long time now, but anime AI was never my strong point. My old games always featured stationary hazards or very simple logic to move something in a single direction or between 2 points.
For our game, we need at least 3 types of enemy AI to have variety in their movement and behavior. One for standard enemies, characters that walk on the ground and follow the player around. One for stationary enemies like turrets, these don't need to move and only target the player. And one for flying enemies, for anything airborne like drones, floating monsters or enemies with jetpacks.
I knew I will have to learn a lot to achieve this. I began making the standard troop AI since it will be used the most. I use the default character blueprint for my base. This class will hold the most common health, damage and detection related functions. Then I created a new AI controller. Like I did with the character, the shared controller will house common functions, mainly perception. To detect the player, Unreal offers 2 components, the old pawn sensing component and the new and modular AI perception component. I decided to use AI perception because I ran into limitations and issues with the sensing component before, and I'm pretty sure this new and shiny component will work flawlessly. I added a cylinder as my placeholder character model and set it up to use my AI controller. Here comes the interesting part, telling the AI what to do. Previously, I set up the logic with blueprints inside the AI controller. It was a mistake. The thing is, creating complex AI logic in blueprints is not only cluttered, but prone to errors. So this time I decided to learn behavior trees. This is a way better solution, because unlike blueprint functions, only one task runs at the time, making it easier to manage behavior in stages. I set up the AI to chase the player and fire at them when in sight. I looked at Quake to use it as reference. Enemies there take a few steps toward the player before stopping and firing. I mimic this behavior by setting a pet toward the player and interrupting the movement after a set time. Then the AI checks for line of sight and fires. I don't want every enemy to get into the player's face, so I made another troop type which zips around and tries to keep distance from the player. Everything was working fine until it wasn't. The AI either ignored the player or tried to shoot at them through walls. When I tried to change parameters on the perception component, the engine crashed. After that, the project crashed every time I tried to launch it. I managed to recover it, but it was scary. Game dev tip of the day: always keep backup saves of your work. I spare you from the details, but after days of debugging I was unable to solve the issue. I looked online and found nothing. I felt like I was the only one who ran into this problem, so I made my own sensing logic. It's basically just a line trace within a radius, checking for line of sight. I can control the sight length and cone angle at runtime and decide what to do each trace. Using my own sensing component, the problem magically went away. In the future, I'm going to handle detection of sounds in the same way to make enemies react to gunshots. It was time to jump into Blender and create a model for the troop enemy. The head went through several iterations, and this is the final result. I quickly rigged the model and sent it to Oscar to animate it.
Neither of us have much experience with character animations, but since Chris is already overwhelmed with technical challenges, I decided to learn the art of animating in Blender. Although the process itself is not particularly complicated, it still took me some time to learn it properly and get used to the interface. For our humanoid enemy, I had to create walking, aiming, shooting, pain, death, and various idle animations. He can also jump in 3 different ways, depending on whether he is jumping up, down, or across. First, I create the keyframes, which are basically the most important moments of the given animation. Once the keyframes are ready, I start fine-tuning the animation, which often involves desynchronizing the movements of certain body parts. This simple trick makes the character's movements much more natural. We had some trouble exporting the animations to Unreal Engine, but after a lot of trial and error, we finally found the right settings. Creating animations is a real art, and I'm fully aware that I still have a lot of room for improvement. I hope that the final animations will fit well with our game.
I imported Oscar's animations and set up the animation blueprint. Our enemies cannot move sideways, so it was enough to blend between an idle and walking. Then play separate animations for shooting and dying. With the AI somewhat working, our project finally starts feeling like a game. It was time to add more. I asked Oscar to make animations for jumping up and down platforms. Then I made a custom navigation link to tell the AI when and where to jump. And here's where I hit the next roadblock. So there's a technique called the root motion animation. It means we can move the whole character just by playing an animation. The problem is I never actually used this. Turned out I messed up the rig, meaning we cannot use root motion without redoing all the animations. So I told Oscar to freeze the jump animation in place and I will make the character jump in code. It did work and the enemies are able to follow the player up and across platforms. I started with the model and created a simple open and close animation. I did not need anything else because the turret will aim by code. Took an unbelievably long time to figure out the rotation of the turret guns. I used some interpolation to make the turret slowly rotate toward the player, making it easier to avoid its fire. I had issues with collision too. Skeletal meshes use simple primitives like boxes, spheres and capsules to calculate collision, but it's not precise. I imported the turret parts in separate pieces and generated collision mesh around them. I used the collision of the static mesh on the skeletal mesh to get an accurate shape for hit detection. With this, the core of the turret is done. I thought creating our flying enemy will be easy after all these. In order to AI characters be able to move from one place to another, they need a path. Calculating a path based on the actual level geometry would be expensive, so game engines use a nav mesh. A nav mesh is like a simplified version of the level, where only the floor is considered. With this simple mesh, the engine can calculate a path based on connected regions. This works perfectly with characters walking on the ground, but what about flying enemies? To navigate in a fully 3D space, we would need a grid of points in the scene, a volumetric nav mesh. Unreal Engine does not have such thing, and I did not feel like creating a system like this from scratch, so we decided on a compromise. Flying AI will not use pathfinding and just goes straight toward its goal. The default movement of the built-in flying character controller looked unnatural and bad, so yet again I made a custom one which makes the movement component apply a directional force toward the target like a gravity pull effect. This looks way better and more natural, like a drone would behave. We decided to make this enemy not fire any projectiles. We already have 3 enemies that do that, so the drone explodes when gets close to its target. The code is there to make drones that shoot at the player in the future. With the flying enemy finished, this milestone is done. I would like to thank everyone who watched our previous devlog and left a comment. Knowing there's interest toward our little game means a lot to us. Sorry for taking ages with this episode. Most of the systems took days to figure out, and I also had to learn about AI in general. Also, we are not working on this game full time, so I only really have time to work on it on weekends. This does not mean we don't make any other progress. I already have a ton of footage about graphics and gameplay for the next episode. But until then, see you next time.